Being able to use scientific notation is an important skill to have, particularly in the study of physics. Because physics studies very big numbers, whether they're very actually large magnitudes such as the mass of a star, or very small magnitudes such as the mass of an electron, they tend to be very large and unwieldy. You don't want to write 67,374,000 over and over and over again in a paper. So scientific notation offers us a way to write it in a more compact manner. So let's look at that. We're going to have to do a brief review of what powers of 10 mean, because scientific notation relies heavily on powers of 10. So if I have 10, let's say to the third power, that means I have 10 multiplied by itself 3 times. So 10 times 10 times 10. And that's equal to 1,000. Note, 3 zeros, 3 is the exponent, and 3 tens. That's not a coincidence. That's always going to be what happens. But suppose we have 10 to the negative third. In this case, we're going to have 1 divided by 10 to the third. That's all that negative sign means. It means it's secretly a fraction. And this is equal to 1 over 10 times 10 times 10. And this is equal to 0.0001. Again, 3 zeros, 3 tens, and the 3 exponent here. The only difference is the decimal point now is on the other side. So it turns out that's always how powers of 10 work. Let's say we multiply a power of 10 by a number. Let's say I have 37, and I want to multiply it by 10 to the fourth. Well, 37 times 10 to the fourth is going to be equal to 37, 1, 2, 3, 4, 370,000. Power of 10 to the fourth gives you 4 zeros, and you move the decimal point, which is invisible at the end of the number, you move it to the right 1, 2, 3, 4 times. You won't always get zeros equal to the number of the power, because, for example, let's say I had 3.7 times 10 to the fourth. Here, you get 37,000. And this is because the thing you're moving is the decimal point. You move it 1, 2, 3, 4 spaces, 1, 2, 3, 4, and you stop. Only when it's at the end of the number will you get zeros equal to the exponent. But what happens if you move it, if you multiply by a negative exponent? It seems like it might be logical that it moves the other way, and indeed that's what happens. So suppose I have 37 times 10 to the negative fourth. Now I get 0.0037 because I've taken this invisible decimal point and I've moved it 1, 2, 3, 4 spots, and I've filled in the empty holes with zeros. Relatively straightforward. So let's see how we can use this to represent very large, unwieldy numbers. So suppose I have 6,370,000. And I want to write that in scientific notation in a more compact way. Well, scientific notation, the standard is that you're going to have the decimal point be right after the first integer here. So we're going to have 6.37, and you're going to multiply that by some power of 10. 6.37 times 10 to the something. And this needs to give you this number. So 6.37 is a lot smaller than 6,370,000, which means that we need a positive exponent. Well, what is that exponent going to be equal to? Well, our decimal point, 6.37, moves 1, 2, 3, 4, 5, 6 spots in order to give you the first number, which means we're going to have 6.37 times 10 to the sixth. Now, what if we had the opposite? What if we had 0.00000637, for example? We're still going to have 6.37 times 10 to the something, but this time the something is going to be, we need to move the decimal point. If we have 6.37, we need to move it 1, 2, 3, 4, 5, 6 spots to the left. If we want to move the decimal point to the left, it has to be -6. So that's how you convert a number that is large, whether it be very, very small or very, very big, to scientific notation. If you want to convert a number from scientific notation to standard notation, that's also pretty straightforward. So suppose you want to convert 2.9 times 10 to the third, and you want to convert that to a normal number. Well, positive number means it moves to the right. So it moves to the right 3 spots. Let's actually write it here. 29 moves 3 spots. 1, 2, 3. So 2.9 times 10 to the third is 2900. Similarly, if I had 0.0029, oh sorry, I want to convert to standard notation. Suppose I have 2.9 times 10 to the negative third. Well, here we're going to move it 3 spots to the left. 1, 2, 3. And this is 0.0029. So really, multiplying by 10 raised to the different powers of 10 is really just a way to move the decimal point around and give you numbers that are nicer. 2.9 or 6.37 times 10 to the negative 6 is a much nicer number than 0.00000637. It's much easier to say. It's much more convenient in a lot of respects. So that is pretty much all there really is to scientific notation. It's all about being able to transform numbers from and to scientific notation. You can also put this into your calculator. You can put in 2.9, then just times, and you can say 10 raised to the whatever power you want. So often graphing calculators even have buttons that are sometimes capital E's. It might look something like this. So you can use that button. Often you can just put in 2.9 and then hit the EE button, and then just write the power of 10 that you want, so to the negative third, and this will output 0.0029. This EE kind of replaces the 10 to the something. Yeah, so that's scientific notation.